For 10,000 generations, we've looked up, that golden disk in our sky, the source of warmth, of life, of time itself. It rose with the first humans, illuminated every civilization, and witnessed every story ever told. We built sundials to track it, temples to worship it, and our entire biology around its rhythm. It feels eternal, constant, the one thing we can always count on. But what if I told you that everything you see, every sunrise, every sunbeam, every moment of daylight is temporary? That humanity's expiration date has already been set, not by climate change, not by asteroids, but by our own star. Today, we're going on a journey 8 billion years into the future to witness exactly how the sun will die and discover why the most terrifying changes begin much, much sooner than you think. The sun has been burning for 4.6 billion years. It's middle-aged now, stable and predictable, but like any star, it's living on borrowed time. Every second, it consumes 600 million tons of hydrogen fuel, and when that fuel runs out, the clock starts ticking for everything in our solar system. Let's start with the first catastrophe, and it happens surprisingly soon. In about 150 million years, continents will collide into a new supercontinent. But that's just geology. The real change comes from above. As the sun's core accumulates helium ash, it actually gets hotter and brighter. Not dramatically, just about 1% every 110 million years. But this slow creep has devastating consequences. By 600 million years from now, CO2 levels in our atmosphere plummet. Photosynthesis becomes impossible. Complex plant life dies out. Then, around 800 million years, the real horror begins. The Earth's temperature reaches the runaway greenhouse threshold. Our oceans don't just get warmer, they start to boil. Imagine steam rising from every ocean, every lake, every river. The water cycle accelerates until our atmosphere becomes a thick, suffocating blanket of vapor. This is the Great Evaporation, and it happens while the sun still looks perfectly normal in our sky. Our beautiful blue marble becomes a scorched, steamy hellscape, and we still have 4 billion years until the main event. Now we reach the true transformation. Around 5 billion years from now, the sun exhausts its hydrogen fuel. The core collapses under its own weight, heating up to 100 million degrees Celsius, hot enough to start fusing helium into carbon and oxygen. This releases an enormous burst of energy, and the sun begins to swell. It becomes a red giant. First, it swallows Mercury, then Venus, then it expands toward Earth. There's actually a scientific debate here. Some models show the sun expanding just to Earth's current orbit, where our planet might survive as a charred, airless rock. Other models show it expanding past Earth, consuming our world entirely. But the 2023 Astrophysical Journal study of 5,000 simulations gives us numbers. 68% chance Earth escapes engulfment but is completely dead. 32% chance of total consumption. Let me pause here and ask you something. If you could send one message to humans 5 billion years from now, what would it be? Comment below. We'll discuss the most profound answers. Now back to our dying sun. Long before physical engulfment, Earth's surface temperature reaches 1,000 degrees Celsius. Rocks melt. The crust becomes liquid. If any trace of humanity survives to this point, and that's a cosmic if, it ends here. But death in space is often beautiful. As the red giant phase ends, the sun sheds its outer layers in a spectacular display. These expanding gas clouds form a planetary nebula,
a glowing, colorful halo that would be visible from nearby star systems. At the center remains the Sun's corpse, a white dwarf. This white dwarf is incredible. Though only the size of Earth, it contains half the Sun's original mass. A single teaspoon of its material weighs 5 tons. It will glow with residual heat for trillions of years, outliving the current age of the universe by a factor of 1,000. But here's the twist that changes everything. Recent research suggests that while the inner planets are destroyed, the outer solar system might actually become more habitable. Jupiter's moon Europa, currently covered in ice, could develop a global ocean as the ice melts. Saturn's Titan, with its methane lakes, might stabilize into a temperate world. For a brief cosmic window, the outer solar system could be the most life-friendly it's ever been. This raises profound questions. If humanity survives to witness these changes, will we still be human? Evolution alone would change us dramatically over 5 billion years. Add technological enhancement, and our descendants might be as different from us as we are from single-celled organisms. Would we become interstellar nomads? Would we build Dyson spheres to capture the red giant's energy? Or would we upload our consciousness into machines that could survive the harsh new environments? And what would we take with us? The Voyager Golden Record, currently speeding into interstellar space, will outlive the Sun by billions of years. It carries sounds and images of Earth. What would your addition be? A piece of music? A personal message? A scientific formula? Our legacy might not be in biology, but in information, data that could survive even our star's death. Looking beyond our solar system gives us perspective. Red dwarf stars like Proxima Centauri live for trillions of years, 1,000 times longer than our Sun. Their planets could host life for incomprehensible durations. The TRAPPIST-1 system has 7 Earth-sized planets in the habitable zone of such a long-lived star. And we're discovering that most stars have planets. The universe might be filled with civilizations watching their own suns age and die, each facing the same cosmic deadline we do. So where does this leave us? With a choice. We can see this timeline as doom, an inevitable end to everything we know. Or we can see it as the ultimate perspective shift. The Sun's lifespan gives us a deadline, yes, but it also gives us time. 500 million years until the oceans boil. That's 20,000 human civilizations back to back, enough time to become something we can't even imagine. In the words of Carl Sagan, as he looked at the pale blue dot, that's here, that's home, that's us. Our Sun gave us that home. Its death will take it away, but between those moments lies all of human potential. Every discovery, every artwork, every act of love, every scientific breakthrough, all happening on borrowed time under a temporary star. That temporary nature is what makes it precious. The Sun isn't dying, it's living, and so are we. For a brief, beautiful moment in cosmic time, we get to witness the light.